Today I'll talk about major and minor losses in piping system. Here water is flowing through an iron pipe system. The piping system includes several horizontal and vertical pipes, elbows and fittings. Calculate the inlet pressure at point 1 considering friction and losses due to the fittings. Now here we have to calculate the inlet pressure at the pipeline. In this piping section, so here L1 is the one horizontal pipe is connected with elbow. Here this is 90-degree elbow, loss coefficient that is 1.5, and the length of L1 is 4.572 and diameter of this that L1 pipe, so that is 1.905 meter. And then one vertical pipe is connected, again here another elbow. Okay, so that vertical length is 3.048, diameter is same. Then again one horizontal, so L3 that length is 1.524 meter, again there is another elbow, and then again one vertical, that length is 3.048, and here again another elbow is connected, and then again that L5 horizontal pipe is connected, and then there is another fully open globe valve. Here loss coefficient is K is equal to 10, and then another pipe horizontal piping section, that is length is 4.572 is connected, and finally one fully open faucet with loss coefficient K is equal to 2 that is connected with the pipeline, and outlet diameter of the faucet is that is 0.127 meter. Now here that water is flowing through the pipeline and flow rate is given, that flow rate of this water, that is Q is equal to 2.73 meter cube per hour. Now here I have to calculate what will be the pressure at the inlet of the pipeline. So in that point 1, so what will be the pressure at this point? So now, so following up, so what are the data is given? So one is flow rate. Flow rate is given, volumetric flow rate, that is 2.73 meter cube per hour. So now if we want to convert meter cube per second, so we have to divide with 3600 value. So that if we convert meter cube hour 2.73 meter cube per hour to meter cube per second, so value will be 0.00758 meter cube per second. So pipe 1 section 1 diameter D1 is 1.905 meter, and outlet diameter that faucet here, so that is 0.127 meter, and roughness, so it is the iron pipe, that epsilon means roughness is given, roughness of iron pipe, that is 0.15 millimeter that is given, and loss factor or loss coefficient elbow, that K elbow, that is 1.5. Here 1 2 3 4 elbows are there, and one globe valve, fully open globe valve, that K value is 10, and faucet, one faucet, fully open faucet is connected at the end, so that K value is 2, and vertical length, that height difference, so here the two vertical pipes, so this is one vertical pipe, another vertical pipe, so height difference is this L4 plus L2, so that is something 6.096 meter. And water properties, rho is you can take as a 1000 kg per meter cube, and viscosity is 0.001 pascal second. Now first using continuity equation, we have to calculate what will be the velocity at the 2 points, point 1 and point 2. So Q is equal to, we can write A1 V1 is equal to A2 V2 from the continuity equation. Now we first calculate the velocity at the inlet and outlet. So first we have to calculate A1 cross sectional area at point 1, so that is pi D1 square by 4. So V1 will be Q by A1, and A2 pi D2 square by 4, and V2 will be Q by A2. So Q we know already. So A1, that is pi 1.905 whole square by 4, so that is 2.849, and V1, so the Q by A1, so that will give V1 is 0.00266 meter per second, and A2 pi into 0.127 whole square by 4, that is 0.01267 meter square, and V2 will be Q by that area, so that is 0.0598 meter per second. Now after getting that velocity at that 2 point 1 and point 2, now we have to calculate what will be the Reynolds number. So based on the Reynolds number, we can easily calculate what will be the friction factor. Now Reynolds number Re for pipe 1, so that is rho V1 D1 by mu, so that is 1000 V1 is TPL naught, point TPL naught 266 into D1 1.905, because all this pipeline has same diameter, and mu viscosity 0.001. So Reynolds number is 507.33. So it is in laminar zone. So since RE is less than 2000, the flow is laminar. So if flow is laminar, so we know easily calculate the friction factor. Friction factor is 16 by RE. So 16 by RE is 507.33. So that is 0.0315. Since the flow is laminar, we will use the friction factor to calculate the head loss due to the friction in the pipe. So after getting the friction factor, first we have to calculate what will be the total length of the pipe. So L is L1 plus L2 plus L3 plus L4 plus L5 plus L6. All these data are given. So what will be the length of horizontal pipe, vertical pipe, horizontal pipe, vertical pipe, horizontal and horizontal. So total length is 19.812 meter. After getting the length, so we can easily calculate what will be the head loss. So total head loss HL can be given by, so HL 4F L by D1 V1 square by 2G plus summation of all K V2 square by 2G. So now here that we can easily do that. So here that F is actually 0.0315. okay, so now that K total, that is 1.5 into 4 elbow, and then 10 is the globe valve, okay, and 2 is faucet, that is 18. Okay, now here we are taking the velocity V2 is 0.0598, but we can consider that velocity is 0. Because the outlet velocity of the gate valve is something, again we don't know, but if the diameter we know, so we can easily calculate, but here we are considering, okay, that is the very small value, so 0.0598 whole square. So now we plug all this value, so 4 into F L by D, then V square by 2G plus that K into that V square by 2G. So that HL will be 0.032877 meter. Okay, so that is the head loss coefficient. So here remember, so we are considering that outlet velocity here, but we must know what will be the velocity here, and due to that here velocity is something 0.00266, but we are taking that V2 square, so maybe there will be slight change of HL if you consider that V1 square. So here HL is 0.032877 meter. Okay, so here if you plug that this velocity, so this value will be small. Okay, so that we can change. Now here Bernoulli's equation in that inlet Bernoulli's equation and inlet pressure calculation. So Bernoulli's equation between point 1 inlet and point 2 outlet is P1 by half rho V1 square plus rho G Z1 is equal to P2 plus half rho V2 square plus rho G Z2 plus rho G HL. Now here as P2 is 0 because it is open to atmosphere, so P2 is 0, so we can directly cancel out. Okay, and rearrange to solve the P1. So P1 will be half rho V2 square minus V1 square plus rho G Z2 minus Z1 plus rho G HL. So here this contribution is, I think, not that much. Okay, so now here, okay, so no, that is also that good. Okay, so now here P1, that is half rho that V2 square minus V1 square plus rho G Z2 minus Z1, so that is 6.096, then rho 1000, G is 9.81 and HL is 0.032877. So now if you do the calculation, so that value will be 1.790, this value, so that is 59743.776, and this will give 322.46 Pascal. So if we add together, so P1 will be 60067.93 Pascal. So that is 60.068 kilopascal. Now if I correct that velocity, so that value will be slightly lower. Okay, so 60.06 68 kilopascal. So at the inlet, so that the inlet pressure that the inlet pressure at the point 1 is approximately 60.068 kilopascal. That's it. Thank you.